Yes. Good morning, all of you. So in the last class, we were discussing about the convolution integral in continuous time domain. And the question that we discussed was x of t is equal to e raised to minus at u of t and h of t is equal to q of t, and you need to compute y of t. So after observing the question, everything is in time domain. It is not n, it is in t. So it is understood that the given system is a continuous time system. So you have to use the convolution integral in order to get the output y of t. And the equation for y of t will go like this: integral minus infinity to infinity x of tau into h of t minus tau d tau. This is the equation for convolution integral, so that we will get the output y of t. Now, after observing this equation, it is understood that the output is a weighted superposition of shifted impulse response, isn't it? Weighted is nothing but x of tau. X of tau is a scaling factor or a constant. So you can consider that as a weighted, and h of t minus tau is a shifted impulse response, and the superposition is nothing but your minus infinity to infinity integration. So output of any LTI system can be considered as the weighted superposition of shifted impulse responses. But as of now, in the question, we have given x of t and h of t with us. But now we need to redefine those x of t and h of t in terms of x of tau and h of t minus tau. Okay, so from x of t, we have to plot x of tau, and from h of t, we need to plot h of t minus tau. I hope it is clear, because as far as the question is, the equation is concerned, we need x of tau and h of t minus tau. But in the question, they have given x of t and h of t. So we need to convert into tau domain, not t domain, tau domain. Okay, so first we will write x of tau. X of tau is given by e raised to minus 8 of u of tau. That is, simply you have replaced t with tau. Simply you have replaced t with tau. And we will try to plot this particular graph. And in the question, they have also specified the condition for A. That is, A is greater than 0, means A is positive. So e raised to minus at will be a exponential decaying signal. Exponential decaying signal. Because A is positive, so minus A will be negative. So the exponential power will be negative. So we have to draw the x of t in an exponentially decaying manner. So what will be the value of the signal at t equal to 0 or tau equal to 0? At tau is equal to 0, we know that e raised to minus a into 0 is e raised to 0, which is equal to 1. So the signal will start from 1 and eventually it will be decaying towards infinity. And why the signal is not confined to negative half? The signal is not confined to negative half because the signal is multiplied by u of tau. And what is the speciality of u of tau? U of tau will exist only for greater than or equal to 0. That is why the entire signal x of tau is confined from 0 to infinity, and we don't have any sort of signals in the negative x-axis. I hope this is clear for you. Any doubts with respect to this plot of x of tau? Why you are not plotting in the negative x-axis? Because e raised to minus a tau is multiplied by u of tau. E raised to minus a tau is multiplied by u of tau. U of tau is 1 only from 0 to infinity. So When you multiply 1 with e raised to minus a tau, it is understood that e raised to minus a tau will be available only from 0 to infinity, and you don't have any signals in the negative x-axis. So this is your first plot, and I will label this as figure number 1. Please take it down. Any doubts, please ask. So I will repeat, x of t is given to you, h of t is given to you. From this, you need to find your output y of t. For finding the output y of t, you need to make use of the equation that is inside the box. This is called as convolution integral. Now, having observed this particular equation, it is understood that you need to plot x of tau and h of t minus tau. Only then you can multiply and integrate. So, from x of t, you will be writing x of tau just by replacing t with the tau. And the signal will be starting from 0 to infinity, because u of tau is a unit step sequence. Its value will be 1 from 0 to infinity. Okay. So, the entire signal will be confining. Okay, now we will be plotting h of t. H of t is given by u of t. Okay, so first all of you plot h of t, and then we will plot h of t minus tau. It is given that h of t is u of t. U of t is nothing but a unit step sequence that will be available from 0 to infinity with a value 1. But we need h of t minus tau. So to plot h of t minus tau, what you have to do? First you plot h of tau, then you plot h of minus tau, then you plot h of minus tau plus t. This is the steps that you need to follow.
Sir, shouldn't the graph be h of tau?
Yeah, h of tau. So first I just plotted h of t, and I would like to replace t with the tau. That's all. Okay. So in x-axis, you will be replacing t with tau, so that it will become h of tau. Now, after plotting h of tau, then you will go for h of minus tau. That is nothing but your time reversal. So when you take this time reversal, the graph will appear to the left side of your vertical axis. Now you will be plotting h of minus tau plus t. H of minus tau plus t. See, for your information, already we have started entering your attendance in the continuum. Okay. And we will be monitoring the attendance from the Zoom session. From the recorded Zoom session, I will be monitoring attendance. Accordingly, only I'm going to give attendance from now onwards. So please ensure that you have to join to the Zoom session to get the attendance. And accordingly, we will move from today onwards. Okay. Not from today. Already I have started ended. Okay. So Sayan, you can convey to your friends that they have to attend the classes mandatory.
Yes, sir.
So when you shift h of minus tau plus t, it is understood that this graph will be shifting towards right side by t units of time. Okay. So I will assume that t is positive. T is positive means it is understood that it is right shift, isn't it? When t is positive means it is understood that it is right shift. But what happens when t is less than 0 or negative? It will be going towards left. Okay. And so as of now, I will be assuming a positive shift for the signal, so that it will be shifting towards right by t unit of time. I don't know the value of t in fact. So we need to take appropriate values of t, and then we need to proceed. So all of you draw h of minus t plus minus tau plus t. This is your h of t minus tau. And let it be figure number 2. Already figure number 1 is plotted, that is your x of tau, and figure 2 is h of t minus tau. Now I will be plotting these two again so that I can compare and write the answer. So first I will be plotting x of tau versus tau, then I will be plotting h of t minus tau versus tau. X of tau was a exponentially decreasing signal from 0 to infinity. Now h of t minus tau is a shifted signal from minus infinity to t. Now I will take the first case because I don't know the value of t. So I have to assume different values of t. Accordingly, you can write the output. Suppose t is less than 0 means what is the concept? T is less than 0 means it is negative. So how will this h of minus tau will get shifted? If t is negative means how this h of minus tau will get shifted? Any idea? Tell me. If t is negative means how this h of minus tau will get shifted either towards left or towards right?
Sir, it would go left. It would go
Yeah.
towards left.
Yes, it would go left. So you just plot a left shift, that is the signal h of minus tau will shift towards left by t units. Okay, so this will be your t minus tau if t is negative. Now you compare x of tau and h of t minus tau. You compare these two graphs. Is there is any common interval where both the signal is existing? No, right? One is existing from 0 to infinity, the other one is existing from minus infinity to minus t. Because h of minus tau, it was from minus infinity to 0. So when it shift towards left means, it will come from minus infinity to minus t because t is negative. So there is no common interval where both the signal is existing. One is from 0 to infinity, second one is from minus infinity to minus t. You can see, obviously you can see there is no common time where both the signal is existing, which means that when you multiply this x of tau and h of t minus tau from the time minus infinity to infinity, either one will be 0 during one duration or the other one will be 0 during other interval. So when you multiply this, your answer will be 0 for this particular case. Because there is no common time in which both the signal exist simultaneously. I hope it is clear for you. Any doubts? Please ask. If any doubts, please don't hesitate to ask. You can ask. Now I will go for the next case, case 2. That is t greater than 0. As of now, we have discussed t less than 0. Now you will go for t greater than or equal to 0. Why we are putting equal to 0? Because it is a continuous time integral. No, continuous time. T less than 0, we have finished. Now we will go for t greater than or equal to 0. If t is greater than or equal to 0, means t will be a positive value or t can be here also. Correct? If t is 0 means, h of t minus tau is equal to h of minus tau itself. Means the signal will be this only. H of minus tau, the previous signal. Correct? This one. But when t is positive, you can see the graph will be as per your figure number 2. This was your figure 2. This was your figure 1. Now you compare these two figures. What is the common time the signal exists? What is the common duration during which both the signal coexist? One is from 0 to infinity, the other one is from 0 to t. So what is the common time?
So 0 to t.
Yeah. One is from 0 to infinity, the other one is from 0 to t. And we have assumed that t is greater than or equal to 0. Either t can be over here or t can be over here. So anyway, the common time will be 0 to t. Now, you know the equation. It is minus infinity to infinity x of tau into h of t minus tau. But since the common limit is 0 to t, I will replace the new limit integral 0 to tau t x of tau into h of t minus tau d tau. Now, what is x of tau? X of tau is e raised to minus a tau u of tau. X of tau is e raised to minus a tau u of tau, and h of t minus tau is, what was h of t? H of t was u of t, isn't it? H of t was u of t. So h of t minus tau will be u of t minus tau. So these two terms you need to substitute over here in the integral. So your output equation y of t will be integral 0 to t. Instead of writing x of t, you can have e raised to a tau. You don't write u of tau because it is 1. H of t minus tau is u of t minus tau, that is also 1. The amplitudes are 1, isn't it? If you take a unit step sequence, the amplitude is 1. So the only parameter that is left out here is e raised to a tau into 1 into 1. That is e raised to a tau d tau. E to the power a tau d tau. Now you integrate this and tell me the answer. E raised to minus a tau, right? I think it is e raised to minus a tau. Yeah. The given question, it is e raised to minus a tau. Yes. Now you integrate and apply the upper limit minus lower limit and tell me the final answer.
Sir, 1 minus e power minus 8t divided by a.
Yes, very good. Very good. Others can also respond. Why you are not responding?
Same answer, sir.
Same answer. Okay. So
Same answer, sir.
what is that?
So 1 minus e power minus 8t divided by a.
Yeah. So when you integrate this, you know, e raised to minus a tau divided by minus a is your integral, and you are there to apply your limit from 0 to t. So first I'll take minus 1 by a constant, isn't it? 1 by minus a is nothing but your minus 1 by a, that can be taken outside. Then you apply the upper limit. Upper limit is e raised to minus 8t minus lower limit is e to the power 0. E to the power 0 is 1. So answer will be minus 1 by a into e raised to minus 8t minus 1. Now you can take this minus to bracket. So it will be 1 minus e raised to minus at whole divided by a. The condition is t greater than or equal to 0. Now, you have got both the outputs for different cases. So first case was t less than 0 and second case was for t greater than or equal to 0. For t less than 0, your answer is 0 because you don't have any common signals that is existing in common duration. So there is nothing to multiply with each other. Anything into 0 will become 0 itself. But for t greater than or equal to 0, your output equation will be 1 minus e raised to minus at whole divided by a. Now I want you people to write the final equation after observing these two cases. I need to merge these two cases together and write a common answer, a single answer. How can you do that? Just think and tell me.
Multiply by u of t.
Very good. Who was that?
Lokesh.
Yeah, Lokesh, very good. That is, your output is existing only for t greater than or equal to 0. For all other cases, it is equal to 0, right? So, while writing your final equation, what you can do is the term what you have got, that is 1 minus e raised to minus at whole divided by a multiplied by u of t, because this u of t is existing only for t greater than or equal to 0 and its value is 1. Isn't it? So anything into 1 becomes that term itself, but that is existing for t greater than or equal to 0. For all other cases, it is equal to 0. That is why this is the way of writing the final equation if a signal is existing only for t greater than or equal to 0. So complete it. All of you take down the notes. If any doubts, please ask. So what was the steps? X of t and h of t was given to you. First, what you will do, you will write the equation for convolution integral. Then you will be plotting x of tau. After plotting x of tau, you will be plotting h of tau. Then you will take the reversal, that is h of minus tau. Then you will plot h of minus tau plus t, so that it will be shifting towards right side by t units. But the value of t is not known for us. So I will assume t as negative case and then t as positive case. So first I will take t less than 0, so that this h of t minus tau will be entirely shifting towards negative side. So when you compare those figures, it is understood that there is no common term or common duration during which both the signals are existing simultaneously. Therefore, one or the other term will be 0. Therefore, anything into 0 will be 0 only. So y of t is equal to 0. This is your y of t is equal to 0. Condition is t less than 0. Now, after finding this, you will go for the second case, that is t greater than or equal to 0. Means your impulse response is being shifted towards right side by t units. So after observing the previous two figures, figure 1 and figure 2, it is understood that the common duration during which both the signals existing will be from 0 to t. That is why we have gone with the integral 0 to t of tau into h of t minus tau d tau. And you will not take u and all because the value of u is 1. So the only term left out is e raised to minus a tau into 1 means e raised to minus a tau itself. Then integrate it, apply the upper limit minus lower limit, simplify it. So you will get another answer. So you have got two different answers for two different time instants. And you are going to merge these two cases together by putting u of t multiplied by 1 minus e raised to minus at whole divided by 8. Any doubts? The concept should be very clear so that you can do some complicated problems also. This is the simple problem where you will have only two cases, t less than 0 and t greater than or equal to 0. Take down the next question. Consider a LTI system. Consider an LTI system with impulse response. With impulse response, h of t is equal to e raised to minus t u of t, and x of t is equal to e raised to minus 3t whole multiplied by u of t minus u of t minus 2. I repeat, h of t equal to e raised to minus t u of t, x of t equal to e raised to minus 3t whole multiplied by u of t minus u of t minus 2. Find the output of the system. Find output y of t. Okay. So tell me the equation for y of t. Maheshwar Reddy, tell me the equation for output y of t. Unmute and speak.
Y of t so is tau into h of t minus tau, sir.
Don't forget to put d tau. So integral minus infinity to infinity x of tau h of t minus tau d tau. So this was the equation
Yes,
for
sir.
this was the equation for finding output y of t. Now observing this equation, first of all we need to plot x of tau. To plot x of tau, first thing you need to do is to plot u of t minus u of t minus 2. So I'll be plotting u of t first. U of t is something which is existing from 0 to infinity and its value is 1. This is your u of t. And u of t minus 2 is a right shifted unit step sequence by 2 units. That is, it has shifted towards right side by 2 units. And observing this, we need to subtract the two signals, u of t minus u of t minus 2, and tell me what is the answer after subtraction. Midun M can speak now. Number 75, Midun. How you will get after subtracting u of t minus u of t minus 2? Tell me, Midun, after subtraction, what you will get? No idea. Sai Kiran, after subtraction of u of t minus u of t minus 2, what you will get? Sai Kiran. Unmute your mic and tell me what you will get after subtracting u of t and u of t minus 2. Shiva, yes. This shows that you are not in the class because you are not responding at
Sir.
all. Yeah, tell me what you will get after subtracting u of t and u of t minus 2.
0 and 1.
0 between 0 and
Sir, amplitude is from 0 to 2.
Between
yeah.
0 and 1.
No, between 0 and 2.
0 to 1.
0 to 2, yeah, 0 to 2. You check when you subtract this from here. This is from 0 to infinity. When you subtract 2 to infinity, you will get a signal from 0 to 2. This is a continuous signal, not discrete. So from 2 only you are subtracting, isn't it? So the result will be till
Okay, sir.
okay. So when you subtract u of t minus u of t minus 2, you will get a pulse like this from 0 to 2 and the amplitude will be same as 1. But you need something like this, that is e raised to, what was the given equation? Yeah, e raised to minus 3t u of e raised to minus 3t u of t minus u of t minus 2. So already we have plotted u of t minus u of t minus 2. Now you need to multiply the signal with e raised to minus 3t. You know that e raised to minus 3t is a exponentially decaying signal. Power is negative, isn't it? Power is negative. But this signal will again exist only from 0 to 2. Why it is not existing in the negative half? Because the pulse, this pulse is existing only from 0 to 2. So you are multiplying this with this thing, right? So again, this e raised to minus 3t will exist only from 0 to 2 because you have a term u of t minus u of t minus 2 along with e raised to minus 3t, which is existing only from 0 to 2. So you will not draw this exponential signal in negative half as well as for time t greater than 2. Okay. So you will have an exponentially decaying signal which is confined only from 0 to 2 and its value will be 1 at t equal to 0 because evidently you can put here e equal to 0. It is e raised to minus 3 into 0, that is e raised to 0, which is equal to 1. So at t equal to 0 you will get 1 and later the signal will become 0 at t. It will decrease exponentially and it will become 0 at t is equal to 2. Why it is becoming 0 at t equal to 2? Because after 2 your pulse is not existing. The pulse is confining only from 0 to 2. Okay. So that is why your exponential signal after multiplying with u of t minus u of t minus 2, it will persist at 2. But you can't say that at 2 it will become 0. I will redraw this once again. I'll redraw this once again, then I'll explain so that you will get more clarity. See, this was your u of t minus 2. And what was your e raised to minus 3t? E raised to minus 3t can be like this. At infinity, it will become 0, isn't it? And its value is 1 at t equal to 0, as I told you before. Now you multiply these two. One is from 0 to infinity, the other one is from 0 to 2. So if you multiply these two, commonly this is 1 into e raised to minus 3t is e raised to minus 3t. But the thing is that it will exist only from 0 to 2. But you don't show the amplitude of e raised to minus 3t as 0 during t because it is getting 0 only at t is equal to infinity. But that we can't show here. Okay. So after multiplying, you will get an exponential signal like this, exponentially decaying signal like this, but you can't say that its amplitude is becoming 0 at a 2. So just you can show a small amplitude like this. Maybe some value will be there. Okay. So this is your x of t. I hope it is clear for you. So at a time t equal to 2, your amplitude is not becoming 0, but it will be less than 1 because it is starting from 1, right? It is starting from 0 and it is approaching towards 0 at infinity. But unfortunately, our signal is stopping at 2, but you don't know what its value at 2. Let it be like that only. Any value, any arbitrary value you can take. So this is your x of t. But when you observe our equation for y of t, we need to plot x of tau. We need to plot x of tau So what we have to do, just you replace t with the tau. Graph and all, it is not changing, only your x-axis and y-axis is going to change. So it will be like this. So this is your x of tau. Now you need to plot h of t next. H of t is e raised to minus t u of t. So we will plot h of tau first, that is e raised to minus t. Again, the value at 0 is 1. So it will be starting from 0 and ending with infinity. At infinity, you will have 0. At infinity, your amplitude is becoming 0. So it is continuously or exponentially decreasing from 1 towards infinity. This is your h of tau. So h of tau is equal to e raised to minus t. So what is h of minus tau? It should be e raised to minus tau. So what should be minus tau plus t? It is e raised to minus of e raised to minus of minus tau plus t, isn't it? So wherever you find t, you will be replacing with e raised to minus of e raised to minus of minus tau plus t.